Hello and welcome back to the lecture of time series econometrics. In this lecture, we are going to deal with the properties of MAA process. In previous lecture, we explained the mathematical form we can express MAA1 process, and that was we simply write yt is equal to et plus some theta et minus 1, where theta is the weight of the observation from the previous period. Okay, now when I actually try to get the properties, so we see basically three different properties to basically check the stationarity. One is mean, so another is variance, and the third is covariance, right? So we see these three properties of the different processes that we basically try to uh, create a model on. Okay, variance, and then we have covariance, right? Covariance. So let us try to see what this mean and variance and covariance are going to look like for a MA1 process. Now, one thing is very clear. The mean is pretty simple here. After doing, you know, uh, finding these properties for different other processes like AR process, random walk model, we should be able to tell what is the mean of the YT value, okay, which is very simply, if I take expectation on the both sides, we know what is the value going to be, because expectation of any error term is nothing but 0. So it is going to be a 0 on for both the terms, right? So expectation is going to be 0. So mean is going to be 0. What about variance? So let me create another. So basically, again I'll write down this YT. Let me use the previous color. We should not change unnecessarily. YT is equal to YT minus 1. Oh, I'm sorry. Sorry. This is a R1 process. Let me. YT is equal to ET plus theta ET minus 1. And if I take a var of both the sides, var of YT, what we get is var of ET plus theta ET minus 1. Now what the right hand side means is basically you can simply sum it up. And why you can sum it up? Because the covariance for these terms are basically 0, because ET and by the definition of white noise, basically the definition of IID, is ET and ET minus 1 are basically uncorrelated, right? So we should not bother about the covariance term. We can simply write down this T minus 1, and it means what? It is just now to have a stationary time series. Now all these ETs are basically, all the error terms are basically IID, so I have sigma square, and I know theta when I use a variance structure, so I'll have theta square, and I'll have a sigma square, so I'll have sigma square into 1 plus theta square, right? So that is my variance structure for the moving average order 1 process, right? So we're going to see how this variance is, like all the properties that you're going to derive are different in different series, and that's going to be the interesting part. Now let me come to the next properties, and that is the covariance structure, okay? And I write covariance as, let me write down, let me again write down the series YT. It will help us to actually sort of connect these things. Y2 theta T minus 1. That's the series for AR1 MA1 time series. Now if I want to have a covariance, okay, so how I want to see the covariance of, say, let me write down, say I will take YT and I will take YP plus H, where H is not a function of T, H is independent of T, H is a lag period, right? So that is what we are interested in, to see how this lag period of any H is being reflected when I actually compute the covariance. Okay, so let me write down this as, let me actually replace these yt values with this above equation, this previous equation 1. Okay, let me write equation 1. So I'll just replace these yt values using the above equation. So let me, so it will be et plus theta et minus 1, then I'll put a comma, and then I'll write, so just replace t with t plus h, so it will be like et plus h plus theta e t plus h minus 1. I simply can write this, there is no problem with this. Now let me expand this. Now this is a bit, it may look a little complex if I expand it, but let's just do that. So what will be the, what if I expand, what we'll get? So we'll get expectation. Say you multiply the first term of the first part, et, and the first term in the second part, et plus h. Then you take the second term, theta cov, not cov, expectation basically. Expectation is basically simply the covariance rule, the way you expand, right? When you can compute covariance. So et plus 1, and I have et plus h, right? That is true. That is great. And then I take so the first term from the first part. So I'll write e of t, and the last also I have to have a theta, right? Yeah. So I have to, let me first, there is a theta in the last term, right? So theta of e of et and et plus h minus 1. And the last part is basically I will have second term for both the yt and yt plus h, which means theta square. Then I use e, and then it goes like et minus 1, and I have et plus h minus 1. Okay, so that's basically what you get once you expand this. Okay, now you can look at it just in terms of the covariance rules. You can actually, what I have done simply is basically you can just refer to, let me just write down this formula. You can just refer to the, in case it looks complex, you can just refer to just simply, this expectation rule. You can simply look at expectation of ax plus by, okay, cu plus dv, something like that. If we expand, so that's basically what you have done. Okay, you will see that.